Good morning, students. I am Andy Lawrence. Today I am going to say about the class, what are the units covered here, and further other things I am going to discuss about today. So first of all, I welcome all of you on the online class on behalf of our department, on behalf of our college, and our principal, correspondence, and all other faculty members. So today, first of all, we can see about what are the for the second year I'm going to cover, and we can see about the things. What are the things we are going to see here? We are going to discuss about that. First, we are going to semester 3 for the second year. This paper 3, and this paper was mainly based on electricity and magnetism. So this electricity and magnetism are subdivided into 5 units. What are the units? First unit, that is the electrostatics, and second unit is current, electricity and transition current, and third unit is thermoelectricity, fourth unit is electromagnetic induction, and fifth unit is magnetism. So by seeing this topic alone, we can say that it's a combination of two things, that is electricity and magnetism. So we are going to see the separate things of electricity and about the magnetism. So so if you see this in a further class, or if you are going to PG or as higher standards, we can say that electricity and magnetism are combinedly to form as electromagnetic theory. So we will see about this in electromagnetic theory in a PG class. Okay. So first of all, I'm going to say about how is electricity generated. So first of all, we have to know separately learn about the electricity and magnetism. So first part, how the electricity is being generated, and then how the electric motors are being working, and then after how the magnet helps to form electricity, generate electricity, how the magnet is generating the electricity, and how the flashlight are being produced by using this method. So first, when we see about the basic thing, first of all, we can say about Faraday Lens Law. Okay, in 1831, Michael Faraday suggested the way of electric voltage could generate by motion of magnet by near the conducting material. If the magnet is passed through the electric material will produce the current. So he is the one who first discovered about the current by means of magnetic material, by means of conducting material also. So after further on, if you see about, if you see after him, his theory, Heisenberg Lens, he also was working on the reality that the electromagnetic force is being generated by using the electric field origined by the magnetic flux. So okay, so after he is the one who discovered in 1835. Okay, so when magnet falls on, first of all, assume as a magnet is falling between the pipeline of copper wire and a pipeline of plastic. Okay, what will happen? So if you assume that if the magnet is passed through the pass through the copper wire, the electric current is being produced, and the flow of the property being very slow, since it produces the electric field. So what the flow of the property is slow because it produces the electric field. So while we see in the plastic, so it is It's contradictory. We can see that the electric current is not produced in the plastic material. So if the magnet is flown through the plastic pipe, it will not produce the current. So it moves very faster. Okay. So there is no electrons is being moved in the plastic material. So no magnetic reaction is being taken place in the plastic materials. So if the assume, okay, see the Faraday's law. Okay, here we are taking that a magnet is inserted towards the loop, that means coil. Okay, if we move the magnet towards the coil, it produces the electric field, and we can see that the electric field is detected by using means of a galvanometer. Okay, so we can see that the deflection is being produced on the galvanometer. So if the movement is very slow, it produces slow vibration. But if the movement is being very fast, the electric current is being flown and the deflection is being moved very fast. So if the magnetic strength is high and the movement of the magnet is very fast, the electric flow will be higher and it produces the electric current in a rapid manner. Okay, so that is the thing. So first, we can say that a primary magnetic field is being produced, and after the eddy current is being produced, and after the secondary magnetic field is being produced. So the electrons inside the conducting material excites the motion. Okay, so the movement of the magnet moves the electrons on the coil, and the coil turns, and the electrons in the coil produce the produce the current, and it is being moved. So this generates the electricity. So if the electrons is being moved from the coil, produce the electricity. Okay, so after this electricity, this production of electricity is called as eddy current. So after this eddy current is generated, the current is being generated. This current generated is called as a secondary magnetic field. So the secondary magnetic field is the current which produced by means of eddy current. Okay, so the electric field can move through the conducting material. We can streamline the motion using the magnet and generate electric current. The flow of magnetic, assume if you are combing your hair, you can see that the flow of magnet is like that of hairbrush. So means the hairbrush acts like that of magnet, okay, flowing magnet. So whether the electrons act as the hair flowing in the steam flows on the motion of the magnet. So electrons acts on the motion of the magnet. So for example, the secondary magnetic field. Okay, so we know that while we are taking a nail and we are wounding the coil on the nail, if you're giving the current on if you're giving the electric current on the nail will act as the magnet. So it's a vice versa. We can produce the electric current towards the magnetic material. We can change the electric current towards the magnetic material and the magnetic currents towards the electric material. So okay, so this is a simple way. Okay, so we can alternate this electric current towards the magnetic to be like that of magnetic material, and magnetic material to be like that of electric current. Okay, so we can produce the electric current magnet by means of wounding a nail by copper coil by giving the electric current which acts like the magnet. Okay, so the eddy current is named because of the one who is boating will make the rod. Okay, so he will push the rod. Okay, it produce the produce the eddies in water. Okay, which means sural வந்து வருதுல்ல. So this sural is called as eddy. So the resemblance of the eddy current is by means of the word comes from this word. Okay, so the swirl means eddy. Eddy is produced from that means. Okay, so if the magnet is very strong, the electric current will be also very strong. Okay, if the magnet is very strong, the current is also very strong. For example, if we keep the copper plate on the glass plate, and under we have having a magnet, then if we move the magnet, the copper coil on the top of the glass will also move. Okay, so this also moves. Okay, so if you keep the aluminum coil on the glass plate, and after we are giving the magnet on the under, it will also move. Okay, if the magnet is being strength is high, the motion of the aluminum or copper coil will be high. Okay, so this is the thing. Okay, so this is the basic thing we are going to see. So here we are going to interlink the electric field and magnetic field. Okay, so how the electric is being produced and how the magnet is being produced. Here we are going to see that. Here we are seeing that. Okay, so here in the model we can see that the coil is being wounded on the cardboard tube. Okay, so the wire, and after it is being wounded on the galvanometer. Okay, so if we pass through the magnet towards the cardboard tube, that is a copper coil, inside the cardboard tube, we can see the deflection of the galvanometer and the current. Okay, how the positive and negative is being gathered. Okay, so we can see that in the next picture that the current on the one side will be positive and the other side will be negative if we move the magnet towards upward and downward direction. That is frequently. If you move that frequently, we can see that the magnet is being moved and the electric current is being produced from one side towards other side. Okay, so this, by this example, we can see that electric motor. So we know that while we are seeing in the olden days, while they are having the bicycle, they used to have the dynamo. Okay, so in the dynamo, it is being attached towards the tire. Okay, so the dynamo will when they are cycling the cycle, the dynamo will rotate. Okay, so it produces the magnet is being moved and the electric current is being produced. Okay, so it's a simple example for you have producing the electric field. Okay, so electric current. Okay, using the dynamo. So in the higher applications, we can see that the windmill and the sea waves are being used towards the production of electricity. Okay, so this mainly these chapters is mainly consist of electricity and magnetism, and the learning between the electricity and magnetism is being discussed here. So today the basic thing how it works and how the electric field and magnet have a relationship between each other, and this relationship shows that it has a greater bond. Okay, when we are going to study, we have to study in a multiple manner, that we have to know all the fields, that we have to know that the electric field and we have to know magnetic field, and a combination of both of that is electromagnetic theory. So in the higher standard we'll study. So this is the thing we are going to see in the higher classes. Okay, thank you. So today's session we are going to conclude. We will continue tomorrow and go through the units and the syllabus. We will see it in a broad sense in the next class. We will share about the okay. So well, we will see about the thing. Okay. So we will see about the other things in the next class. First thing we are going to see about the first unit, which is electrostatics. Okay, so we are going to see next class. We will see about the electrostatics and what are the Gauss law, and then electric dipole, electric induction, electrostatic potential. So other things we will see. Okay, so these are the things we will see in the further classes. Okay, so thank you. Have a nice day. Thank you.